हेलो डियर स्टूडेंट, आज की वीडियो में हम एक वर्क एनर्जी थ्योरम से रिलेटेड प्रॉब्लम को डिस्कस करेंगे। प्रॉब्लम में एक वेज है, जैसा आपको स्क्रीन पे दिखाया गया है। इसमें एक इसकी ये सर्कुलर पार्ट है जिसकी रेडियस r है। इस मास m को स्लोली पॉइंट O से पॉइंट A तक ले जाना है और इसमें हमें वर्क कैलकुलेट करना है। कैलकुलेट द वर्क डन इन शिफ्टिंग दिस चार्ज m फ्रॉम पॉइंट O टू A। इस सर्कुलर पार्ट पर ब्लॉक की सरफेस और कर्व सरफेस के बीच में एक फ्रिक्शन एक्ट करता है जो म्यू इक्वल टू म्यू नॉट एक्स की तरीके से बेसिकली वैरी कर रहा है। देयर एक्स इज द डिस्टेंस अलोंग एक्स एक्सिस। इस प्रॉब्लम को हम तीन तरीके से बेसिकली डिस्कस करेंगे। लेट अस स्टार्ट द फर्स्ट मेथड, दैट इज मेथड 1। मेथड अगर आप किसी इंस्टेंट इस ब्लॉक, मान लीजिए ब्लॉक यहाँ पर है और ये नॉर्मल से थीटा एंगल, लेट दिस एंगल इज थीटा। So there are three forces acting on the block. One is its weight that acts vertically downward W. Another is normal reaction from that surface that acts towards the center. And third one is the frictional force, that is F. Okay. If you proceed this line, this angle becomes basically theta. So we want to calculate the work done, total work done. W will be equal to the work done by weight plus work done by normal reaction plus work done by friction. Since normal reaction n is always perpendicular to the displacement ds, hence work done by normal reaction will be equal to 0. So total work done will be equal to W will be equal to WW plus W force of friction. Okay, this is the basically total work done in shifting this block from point A to A. First, since W is here and W will be equal to basically mg, so the work done in shifting from point O to point O dash, that is the vertical distance r, the work done W will be equal to mg multiplied by r. This is basically minus mgr. Here the total work done will be equal to of negative of this, right? This is equation first. Now we want to calculate the work done by frictional force. If you see here, the W can be break in two components. This is basically W cos theta that act opposite to n. Hence we can write n will be equal to W cos theta, or that can be written as mg cos theta. Okay, work done during a small displacement ds, the work done by this force dw will be equal to dw by friction force. We can write force of friction will be equal to mu times n. Hence the work done by the friction force dw will be equal to F multiplied by ds, or that can be written as mu n into ds, and that will be equal to mu mg cos theta into ds. If we make a right angle triangle here, this is basically dx, this is dy, and this is basically ds. Let this angle is theta. Then we can write from here cos theta will be equal to dx upon ds. On putting down this value here, you can write down dwf will be equal to mu mg cos theta into dx into dx upon cos theta. On putting the value of ds from this equation, or that can be written as mu mg into dx. So we can write this value as dwf will be equal to mu can be written as mu naught x into mg into dx, or that can be written as mu naught mg into x multiplied by dx. You want to calculate the total work done. When block reaches from O to A, the distance covered it along horizontal axis will be equal to the radius r. Okay. So we can write here wf will be equal to mu naught mg. On putting the value of x from 0 to r, x dx, that is wf will be equal to mu naught times mg into x square by 2 on integrating x with respect to x, that is taking the limit 0 to r, we can write this becomes mu naught times mg r square by 2. Mu naught times mg r square by 2. Okay. Hence, total work done will be equal. This work done will be equal to negative work done, negative. Hence, the total work done W will be equal to minus of W due to weight plus W due to friction, or that can be written as minus of minus mgr plus minus mu naught mg r square by 2, or that can be written as W will be equal to mgr can be taken common out 1 plus mu naught r by 2. Okay, this is the first method, that is the total work done during the first method. Now we will use second method, to calculate this one. Okay, the second method. Total work done W will be equal to the negative of work done by weight plus work done by friction, as we have already discussed, right? In shifting, the work done W will be equal to minus of mg into r. Since mu is given as mu naught x, hence we can calculate, and x will be here from x equal to 0 to x equal to r. So we will calculate the total work done by friction, assuming mu has a constant value, that is given as mu equal to value of mu when x equal to 0 plus value of mu when x equal to r divided by 2. And we can simplify here. Mu will be equal to 0 when x equal to 0, the value of mu is 0, plus when x equal to r, the value of mu is mu naught r divided by 2, that is mu naught by 2 r. Hence, work done by the frictional force Wf will be equal to mu mg multiplied by r, that is equal to mu naught upon 2 into mg r multiplied by r, or Wf will be equal to mu naught mg r square by 2. This work done will be negative. Okay, hence again putting the value of these two work, the W will be equal to minus of minus mgr plus minus mu naught mg r square by 2. Okay, on simplifying, we can write W equal to mgr into 1 plus mu naught r upon 2. This is the basically second method. Now we will use third method, that is basically the graph method. Okay, the work done by weight W will already calculated as minus mgr. This is basically third method. And we know that the coefficient of friction is given as mu equal to mu naught x. Okay, hence force of friction will be equal to mu mg, that can be written as mu naught mg x, which is a linear equation. F equal to, this is the linear equation like as y equal to mx. Here mu naught mg is the slope or gradient of this line passing through the origin. Now we want to calculate the work done by this friction force. The work done by this friction force can be calculated using graph like this. Okay, we will plot the graph of this force of friction, that is the graph of like this, and the value when x equal to 0, force of friction becomes 0. This is the basically force of friction. This is distance x, and when x will be equal to r, force of friction becomes mu naught r. the work done by the force of friction dWf will be equal to the area of this triangle, equal to area, and that becomes equal to half into R into mu naught R, mu naught mgr, mu naught mg mu naught R into m, and that becomes mu naught mg into R square by 2. Again, the total work done will be equal to W will be equal to negative of WW due to weight plus negative of friction, work done by friction. That is this. So we can write that is minus of minus mgr plus minus of mu naught mg R square by 2. On simplifying, this work W comes out to be mgr into 1 plus mu naught R divided by 2. Okay, this is the basically third method. So we can solve this type of problem with various types of methods. For more such video, keep watching. Thank you for watching.